up from where we stopped the other days. We some people were there, some were not there. So the chapter oriented topic, Oster's experiment. Oster's experiment. And I will not write, I'll just have a discussion with you on this. We have already learned this. Current carrying wire behaves like a magnet. Okay, Oster found that when a current carrying wire behaves like a magnet, from the experiment, he was actually trying to study heating effect of current through a conductor. And when he had a magnetic compass and current was allowed to flow through the conductor, the magnetic compass deflected, right? And when the current was switched off, the magnetic compass came back to its original position, which said that the magnetic compass must have sensed some what is known as an additional magnetic field, which was created due to the current carrying conductor. Now, when he switched it on, the magnetic field got created. When he switched it off, the magnetic field went away. Okay, there was no more magnetic field, and the polarity of the magnetic field was dependent upon the polarity of the current. So when he had a particular polarity of the magnetic field, the compass deflected on one side. When he reversed the polarity, the compass deflected on the reverse side. Okay, now this was the stepping stone. This is the stepping stone for everything related to magnetism. Remember, in this chapter, our input will be electricity, our output should be magnetism, magnetic effect. So Oster's experiment, agar aapko koi bole, what is the output of Oster's experiment? Current carrying wire behaves as a magnet. The magnetization is sustained till the current flows through the wire. As soon as the current is switched off, the magnetization is lost, and the polarity of the magnetization is dependent upon the polarity of the current that is flowing through the circuit. If the polarity is reversed, the current reversed. Okay, now next, after this, the next thing that we study is, since current carrying wire behaves like a magnet, we take three different forms of shapes of the wire. Ab yahan se thoda sa, it's not difficult, it's easy, but try and understand. So we will first see, our first case would be current carrying. We will be talking about the shape now. Straight wire. So the word itself tells you the meaning. We'll have a straight wire through which the current will be passing through, current carrying straight wire. And what we are interested here to find out is, what is the magnetic field direction? The magnetic field direction. Okay. These are absolutely basics for grade 12. In grade 12, magnetism will have two chapters. One will be magnetic properties and one will be electromagnetism. Whenever magnetism as a chapter comes in grade 12, it will be, हम लोग हिंदी में बोलते हैं magnetism हाथों का chapter है. Lot of rules will be there. Right hand, left hand, palm rule, thumb rule. These will get you confused. So the first some few rules you will learn in grade 10 itself, but इनको भूलना नहीं है. Okay. Now our setup is now like this, that I have a straight current carrying wire. So this is my straight current carrying wire. Okay, and I will be passing electricity through this wire. So let us complete that part. Let's make a, so let's say, okay, and again, and this AB is my straight current carrying wire. So if this is switched on, in that case, let's see the other alternative, that if this is switched on, then current will flow through the circuit in this direction, in this direction, in this direction, this direction, this direction. Okay, is this much all okay with everyone? Okay, we are going to see current carrying straight wire. AB is a straight wire, and all we are interested to find out is what is the direction of the magnetic field through a current carrying straight wire. We'll see different shapes. Everywhere some rule will come. ठीक है? So put Oster's experiment into it. This is a current carrying wire. It will get magnetized, no doubt about that. Okay, if I change the polarity, the current will get reversed. The magnetic polarity will also get reversed. इस क्लास में हमें स्ट्रेट वायर में पोलैरिटी में इतना ध्यान नहीं देना है, हमें सिर्फ मैग्नेटिक फील्ड का डायरेक्शन देखना है और द मैग्नेटिक फील्ड लाइंस. सो वेलकम टू द फर्स्ट रूल. दिस रूल इज नोन एज द राइट हैंड thumb rule. Right hand thumb rule, and this is also known as the corkscrew rule. शैंपेन बॉटल ओपनर देखा है आपने, उसको हम कॉर्कस्क्रू बोलते हैं. इट विल बी समथिंग लाइक, दोनों का डायग्राम देखिए कैसा रहेगा. दैट डायग्राम विल बी, शैंपेन बॉटल ओपनर्स आर लाइक दिस, or it can be a screwdriver also, ऐसे and ऐसे this. And the right hand thumb rule, you have to take your right hand and curl your fingers. I don't know how much nice I've been able to draw. So this is your right hand thumb, this is right hand. Okay, now see how to find out the magnetic field direction. Very important is you have to be, आप पहला ही चीज उल्टा ले लियो हाथ, यही होता है मैग्नेटिज्म में. राइट हैंड, लेफ्ट हैंड नहीं. वो जो आप करने की कोशिश कर रहे हो, स्कूल में पढ़ाया है चैप्टर, वो फ्लेमिंग्स लेफ्ट हैंड रूल है. कंफ्यूज नहीं होना है, मैग्नेटिज्म में बहुत सारे हाथ के रूल आएंगे एक एक करके. राइट हैंड थंब रूल. फ्रॉम दिस डायग्राम, टेल मी, व्हेन यू आर मेकिंग अ सेटअप, you will be knowing where the positive is because you are giving electric current. You know where the negative is, so you look at the wire, you know the direction of flow of current. Adjust, now listen to me, adjust your right hand in such a manner that the thumb is aligned along with the axis of the wire and the thumb points the direction of the wire. ठीक है? The direction of the electric current, sorry, direction of the current. Curl your fingers now. That shows the direction of the magnetic field. So what will be the magnetic field in this case? The magnetic field in this case will all be concentric circles. Okay, कैसा रहेगा? ऐसा concentric circles आएगा, ऐसे, ऐसा. Then one more, just a minute. Okay, so they will be like this. This, then nothing to confuse, I'll explain you. Let me make the figure. Okay, what did I tell you, children? Align your thumb in such a manner, that the fingers then have only one position to curl. Ulta curl to curl kar hi nahi sakte na, you cannot do. They curl like this. So once you curl it, they are all like, it's like this, aisa. So this circles all about. And which directions are the circle rotating? Can you tell me in clock, anti-clock? आप खुद सोच के देखो, ये direction है. It was rolling anti-clockwise. Okay. So in my case, I would say that the magnetic field directions are all like this. Does it make you clear? Okay. It's like this. This is what we have to study. Now in this chapter you will qualify for a lot of case-based questions. Now imagine if I reverse the polarity, then the current goes downwards. Then how do I show my finger? Then it will be like this. And yes, and here we will be doing clockwise rotation. Circle तो अभी भी होगा, circle होगा. कैसा है? This is the current carrying straight wire. Say this is the straight wire, and there will be a plane out here. Imagine that this, I have taken this scale and I have stabbed it through a A4 paper. It is inside a A4 paper. On that A4 paper, you draw circles, concentric circles, and give the direction of the circle as per the right hand thumb rule. Okay. This rule will be used a lot in grade 11 in mechanics when you study cross product of vectors. वहां पे भी यही रूल लगता है. अब corkscrew rule में देखिए कैसा रहेगा. ये corkscrew को उठाइए, उठा के now point the corkscrew in such a direction where the current is going. And if you, how do you operate this tool? When you rotate it, there is a forward feed of the screw. वो screw अंदर चला जाएगा ना. So I want the screw, I want the head to face along the direction and the screwdriver to move in this direction. तो मैं उसको कैसे घुमाऊंगा? ऐसे घुमाऊंगा. Whichever rule is fine with you, you can adapt to that rule. Right hand thumb rule or the corkscrew rule. Corkscrew is very simple. It's a device like this. It's a T type of a device. Now see how we'll do. It's a T device like this. I want it to face in this direction because that's how my current is actually going. Now it has to have a feed along this direction. तो feed कैसे दोगे? कोई भी चीज ऐसे घुमाने से जाएगा ना अंदर. Screwdriver को घुमाएंगे तो screwdriver आगे जाता है. Got it? And if the current is going downwards, then how does the corkscrew look like? ऐसे. इस side घुमाएंगे. The same. Whether you use corkscrew rule or you use right hand thumb rule. So the right hand, so again, recap. First was Oster's experiment, which told you current carrying wire behaves as a magnet. Once it behaves as a magnet, your job is to ascertain the magnetic field lines. Once you get to know the magnetic field lines, you should have a rule. आपको डायग्राम में ऐसे भी दे सकता है. अच्छा बोलिए तो, tell me something. If in your test paper they give you the diagram like this, ऐसा बना दे. This is also a straight wire, and they show that current is moving in this direction. Now how will you apply right hand thumb rule? ऐसे. So the current is going in this direction, and circles will always be perpendicular to the axis of the wire. बट रोटेशन आपको देखना है. इस बार रोटेशन कैसा होगा? नीचे से ऊपर की तरफ, नीचे से ऊपर की तरफ. करंट इस साइड जा रहा है ऐसे. राइट हैंड थंब रूल. देन यू विल गेट इन ग्रेड 12 कॉल्ड द राइट हैंड पाम रूल. ऐसे भी एक आएगा. That's Fleming's left hand, right hand. That you will learn in grade 9 itself, grade 10 itself. Have we understood this? One more revision. First, we are trying to find out two different shapes we will be seeing. Okay, the shapes that we are trying to see are, first is a straight current carrying wire. If the current is flowing straight through a straight wire, how to find out the direction of the magnetic field lines or the magnetic field? This is the magnetic field line. The magnetic field can be found out by the right hand thumb rule. Align the thumb of your right hand along the direction of current through the wire and curl your fingers to form a closed loop. So as you curl it, they form a loop. So that means they will be all circles which are perpendicular to the direction of the current. How do the circles have their orientation? As the finger moves. ऊपर जा रहा है तो ऐसा, नीचे जा रहा है तो ऐसा, इस साइड जा रहा है तो ऐसा, and if the direction was this side, then ऐसा, नीचे से ऊपर की तरफ घूमेगा. Yes.
Is the strength of the magnetic field by how many times the rotation happens?
No. How many times? The strength of magnetic field is always by the concentration of the magnetic field lines. So you see more concentration out here. Whenever you are near a magnet, as I told you, if you are near to any Babaji or Yogi Maharaj, the bhakti is more near the Maharaj. ना इसीलिए लोग लाइन एकदम पहले पंक्ति में जाके बैठते हैं. The more far away you are, the lesser is the magnetic impact sensed by you. So magnetic, remember what was magnetic field lines property? They originate from the North Pole and terminate at the South Pole. Concentration of the magnetic field lines at a particular place tells you how much is the magnetic strength. That quantity in grade 12 will be known as something called magnetic flux. That is lines per meter square. अच्छा आपको एक चीज बोलता हूं. प्रोजेक्टर देखा है आपने? अब this is a projector screen and this is the projector. From the projector's outlet is this much only. All Salman Khan, Katrina Kaif is here. यही जाके इतना बड़ा होता है. So obviously there is a lot of heat. Where do you think if you stand you face maximum heat? The more you are near the projector, the intensity is more. So it's like a magnetic field line, just a flux. That's the concept of flux actually. So if you put a paper, the number of lines crossing from the projector out here will be much less as the number of lines, because these many beams are going and spreading to that much. So सर्कल आपको ये बताता है कि what is the orientation, how a north pole would move. If a north pole is allowed to roam independently, the north pole will move in this direction. ठीक है, clear? Shall we go to our next case? Okay, let's try our next case. Shall we? Okay. Now our next one is we need to study about magnetic field due to a current carrying circular loop. Circular loop means something like a hula hoop now. Okay, I just want to check one thing, otherwise हाँ यहाँ भी rule आएगा. Okay, I just want to see whether we can have preferential deletion out here in this diagram. Let me just check. If that happens, then my job is easy. No, it doesn't allow. Okay, it doesn't allow. Okay. So children, I'm left with no other option, but I have to use, what do you call, my freehand drawing. Okay. Now circular loop. Hang on. Imagine this is a sort of a plain cardboard. Okay, 1 minute. This is a plain cardboard that is kept, and our circular loop of wire will be on this. This is my circular loop. Have you understood? It's a circular loop of wire which is through circular loop means it's a circle. The wire has been bent and made to a circle. However, it was inserted. So maybe see, it's like this. These are the two terminals of the loop. It was a straight wire. I bent it and I made it like a loop. ये side यहाँ से घुसा दिया, ये side यहाँ से घुसा दिया. I may not have this platform also. I'm keeping this platform because it will make things easy for us to understand. Have you understood? There is a circular loop, but you have inserted that loop from this side and this side. Now it is making a circle. Half of the circle is above the table, half of the circle is below the table. Okay? So let's see the direction of current now. As soon as you switch it on, now this is my plus and this is my minus. ये ज़्यादा interesting है. Okay? So our current will be flowing in the positive direction this way, this way, this way, this way, this way, and this way, this way, this way. ठीक है, चलिए ये बना के रखिए, तब तक मैं और दो डायग्राम जरा बना के रखता हूँ. So now we are seeing current carrying circular loop of wire. Shall we try to understand? Okay, same logic. Now imagine, is the earth round? Yes, the earth is round. But if I go from my tower to say your tower, are we going round or do we go straight? We go straight. So if you take a small arc of a very big portion of a spherical object, that arc is almost like a straight line. ठीक है, तो यहाँ वही concept apply करना है. Now this is a spherical loop, it's circular, but if you consider this much portion, देख नेहा इधर देख, if you consider this much, a small portion of it, don't you think a small portion of it behaves like a straight line? This portion also behaves like a straight line. This portion also behaves like a straight line. So if it is straight line, go back to rule number 1, right hand thumb rule. Current is going upwards. That means lot of, see, try and have the understanding. This much portion I can imagine it as a straight line. Yes. Apply right hand thumb rule, then I would say that these are my magnetic field lines. Do you agree? And they are all moving in this direction. Do you dispute with me? No. Right? Fine. This is also a straight line. But यहाँ कैसा हो रहा है? So here also we will have straight line, again circular loops. But what will be the direction?
This is clockwise.
This is in this direction. This portion of the wire, first listen, this portion of the wire is a straight wire. Current is going upwards. So right hand thumb rule tells me circles will be, that's why I made this table. The wire has gone through the table, right? This is a portion of the spherical wire. It has gone through the table. So this is a straight line, this much portion. Magnetic field lines will always be circular, no doubt about that. What is the direction? Apply right hand thumb rule. So I find them that they are rotating in this direction. But here, same case. So let me show it like this. In this case, the current is going upwards. In this case, the current is going downwards. So here also it will be circle. But what will be the direction? The directions would be all this side. Yes. पहले बोलो ये समझे हो कि नहीं, then we will answer our questions. How many of you, I'll take your question, just 1 minute. How many of you understood this, what I'm trying to say? Have you understood? It is to find the magnetic line field for a current carrying circular loop. A circular loop, which is a big loop, a portion of it can be assumed to be a straight line. And once you make a loop, you always know where the direction of the current is going. So if you look at this arm, the current is going in which direction, beta? Upward direction. So put right hand thumb rule. Circles will be there in both cases. Question is, how is the circle rotating? This circle, the field will be always in this direction. See, my fingers are in this direction, so the arrows are in this direction. Whereas here, it's downwards. My fingers are in this direction, so the arrows are coming from here and going there. Coming from here. Have you understood? क्या अर्जुन, क्या प्रॉब्लम हो रहा है? Are you okay? Don't say okay just because I'll get angry. No, it's not about that. You have a paper. Through it, the wire is coming out like this. Which direction? There are two wires. One way the wire is like this. One side the wire is in this manner. ऐसा है, समझ लो. अगर for this side, the current is pointing upwards. For this side, the current is pointing downwards. It will be circle in both cases. You just have to see what is the orientation of the circle. Try and do on your own. You use your right hand. You have to feel it. Yeah.
We observe opposite directions of the magnetic fields.
Hmm.
What happens if when these magnetic fields happen?
Right at the center, you won't find any circular line. सीधा हो जाएगा वहाँ पे.
There is
सीधा हो जाएगा एक जगह पे जाके. Contact तो हो ही नहीं सकता है. ये इस साइड घूमेगा, ये इस साइड, and in between you will get straight. So that is the null zone of magnetization. This side, one parent is pulling, this side the other parent will pull. So this point becomes, he is asking me to go in clockwise direction, this fellow is asking me to go in anti-clockwise direction. Just like we say, na, the point where both Atlantic and Pacific Ocean meets, what does it happen? It's like that sort of a point. Have you understood this thing? Now in this we have to also know what is the polarity. First is direction of magnetic field. Next you should also know what is polarity. ठीक है? Polarity के लिए, again, I will give you one desi formula that will help you. If that doesn't help you, we will see how to remember normally also. The desi formula to understand polarity is, always remember this abbreviation. CWS, ये मूवीज के लास्ट में ही आता है CWS. If you see Australian broadcasting anything, they will say CWS at the last shot when titles roll over. CWS means if you are finding the current to move clockwise, इधर देखो, लिखो मत, आप कुछ नहीं जानते उस चैप्टर के बारे में. It is magnetism is all about viewing the board. CWS, I will say it's very easy. CW stands for clockwise, S stands for south pole. Now how to decode it? अगर मैं नहीं बोलूंगा आप कैसे समझोगे? If you look at this particular loop and you find a loop in which current is flowing in clockwise direction, in this current is flow, which one current is flowing in clockwise direction? You tell me. Second one, as you observe, Neha is observing this. She finds current is flowing in clockwise direction. So the one face of the loop that is facing Neha is south pole. That means अगर CW के जगह CCW है counter clockwise, तो north pole होना पड़ेगा. Now see how the beauty of this is. We'll not see this one. You might be thinking, sir, this is counterclockwise, so it will be north pole. नहीं. अब नेहा इस side है ना? You make Zoe stand on the other side. Try to imagine. How will Zoe see the current? She will see the current flowing in the anti-clockwise direction.
Yeah.
How are you seeing my hand is moving? How are you seeing? Anti-clockwise? How am I seeing? You will be seeing clockwise. You are seeing clockwise, madam. You are seeing clockwise. How am I seeing? So from my side it will be north pole, from your side it will be south pole. Again, remember the abbreviation CWS. CWS stands for clockwise south. From the direction that you are watching. From the direction that you are watching, that I am watching, right? So hang on, let me see if I have the stuff. Just take care of the stylus. 3 times it has fallen after I purchased the board. Okay, let me see if I have it. Yes, you're lucky. I have. It's exactly like this. The scenario is like this. This is a current carrying wire. Have I made a loop out here? It's a loop, right? Now, I am facing the loop from this side. You're looking from that side. You take the current in such a manner that it is clockwise. आप अपना हाथ से बनाओ clockwise. How will you see? Clockwise, right? So you are seeing south pole. Move your hand clockwise. I am seeing that your hand is moving anti-clockwise because I'm seeing it from the other end. So from my side, it is north pole. Obviously, a magnet has to have a north pole, south pole. Fridge magnets, have you seen? Or the magnet that is there on my this is a disc magnet. One face has to be south pole, one face has to be north pole. Problem is that these are permanent magnets. You are trying to do magnetization with a current carrying wire. Now this is called a loop. As I wire लेंगे, this is a current carrying straight wire. This is a current carrying loop. Does it look like a loop? Yes, it looks like a loop. Right? So, in this case, our current is moving in what direction? Clockwise direction. So, there is a diagram way to understand it also. How is the current moving? In this direction, right? The current is moving in clockwise direction. This. What is the letter you see?
Yes.
South pole. How is the current moving here? North pole. Many people find this difficult to understand. That's why I abbreviate it as CWS. Now you can draw whatever you want to draw, and while drawing, if you land up in any doubt, please ask. First you learned current carrying straight wire, right? Okay. Here we have so two more things we will see here. The magnetic field, okay? The magnetic field that is created, the magnetic field is directly proportional to the current flowing through the loop and inversely proportional to the radius of the loop. Obviously, the more far away you are from the loop, loop jitna chota hoega, utna badhiya magnet banega. I don't know if you have ever broken a cell phone or something other, you will see a lot of copper springs jaise cheezein nikalti hai. Those are all called solenoids. देखना उनके radius कितने छोटे होते हैं, very very small. Those are all magnets. So larger is the radius of the loop, weaker is your magnet. So is this a strong magnet? By the way, it has many loops. Now we will extend our study to many loops. इतना देर तक एक ही loop था ना? This is a magnet. The loop has got a smaller radius. Agreed? वहीं अगर इसके रेडियस को बड़ा कर दे तो this magnet will be a weaker magnet. So far you have studied one loop. Now we are going to study many loops, and that will give birth to the next concept, which is known as a solenoid. Have you seen old days telephone handsets? And in the handset, have you seen the wire that connects the cradle to the bend? हाँ, तो यहाँ भी वैसे ही bend करेंगे अभी. Next, we will study something like this. This is called a solenoid. ऐसा spring जैसा बन जाएगा. This is a solenoid. This is the next thing to study. So, children, keep remembering the property of the magnetic field. In the straight wire, we said that the magnetic field is directly proportional to the current, that we did in Oster's class itself, the first class itself. And the polarity is sensitive to the polarity of the current flowing through it. Here also it will be sensitive. You just change the direction, the south pole will become north pole. Understood? Here we understood one more thing, that the magnetic field is inversely proportional to the radius. जितना छोटा loop होगा उतना बेहतर magnet बनेगा. ठीक है? Can I rub this portion? And are we ready to go to the next one? इससे 100% case based question डालेगा आपको. ये and Fleming's left, because there is hardly anything in this chapter for you all apart from these rules. CWS. If you observe, now please understand, so far the diagrams have been made very cutie sweetie for you. Like you are seeing the loop in this direction. Loop, अभी loop ऐसे है ना, आपको सीधा दिख रहा है. Loop ऐसा भी हो सकता है. Yes. Right now the loop has been made facing you. The loop could be like this also. And you are standing from this side. Then you have to understand, imaginarily stand in front of it and think which direction the current is flowing. चलो वो चीज देखते हैं अभी. इसमें न्यूमेरिकल्स नहीं है इस चैप्टर में, आपको नहीं है. No numericals. Right. The next one is magnetic field. Everything you will study numerical with in grade 12. Magnetic field due to a solenoid. SOLENOID. So सबसे पहले हमें solenoid सीखना है. What is a solenoid? So a solenoid. First understand what is a solenoid, okay? A solenoid comprises of copper wire which are closely wound next to each other, but that copper wire is insulated. Hang on, get a feel of it. So a solenoid consists of copper wire, okay? So it will be copper wire which are closely wound to each other, ऐसे करके. But this copper wire is insulated. Now you might have seen this. You open any purana tape recorder, cell phone, anything. This item has to be there. Okay, it will be there in any of these devices. Insulated, but you'll say, sir, when they opened up my hand, what you call mobile phone and all, I saw it exactly in copper color. But you say this is insulated. Insulated means like this wire. This wire is insulated. Do you understand? The black color rubber is insulating. In other words, I'll get a shock. Copper is inside it. But solenoid is made up of insulated copper wire, but it's soaked like copper. So this has been actually soaked in one insulation solution, so that color remains barkarar. But if you take a knife and you start scraping it, na, powder will start falling. The insulation powder. It's like, do you know the manja in kite flying thread? ये manja जैसा है. It is soaked in manja. So it is insulated. आपको देखने से लगेगा insulation नहीं है, इसमें बराबर insulation है. कलर नहीं है, सिरेमिक इंसुलेशन कर दिया है. If I put a sellotape on your bangle right now, golden bangle, it will be still golden in color only, na? But is it insulated or not? Insulated. So similarly, I can also nowadays ceramic glues are also available. So that if you put those glues, what do we do for bathroom tile leakage? Epoxy ceramic glues. Take the brush and just paint your bathroom tiles. Your tiles will look as if they are tiles, but a small coating has been made. Okay, have you eaten chikki? So chikki mein the peanut chikki that we get, have you seen? It's like a transparent layer of jaggery, and inside it the peas can be seen. So the peas have been insulated. तो ये भी थोड़ा वैसा ही है. इसमें copper color रहेगा, but the copper is all insulated. So what is a solenoid? Let's first understand what a solenoid is. क्योंकि वो नहीं समझेंगे तो हमें problem होगा. Solenoid is a closely wound circular loops of insulated copper wire, so that if one line wire is touching the other wire, then one loop is touching the other loop, it doesn't make any difference. और इसको बड़ा बढ़िया से बनाते हैं. कैसे बनाते हैं? Even you can make at home. Solenoid means take one rod or the baलन and then just tie winding it. ऐसे wind करो. This is also a solenoid. और इसको फिर tight करके wind करके खोल दो. ये solenoid बन गया है. यही solenoid है. But here, although this is a grade 9 stuff, still I'll tell you, the length of the solenoid is marginally greater than the radius. बात समझ में आया? Means this will be very long and the radius will be very small, and the number of turns is high. Do you get it now? Very fine wire, and then take it out. So, and imagine, always remember that the length should be considerably more, because in grade 12 when you will do derivations, you will always take this into consideration. L much greater than R. We don't say R, we say A. A is the radius. Not important for you, but you should know this. And the number of turns is high. This arrangement is known as a solenoid. Now we will make current to flow through this solenoid, because we are interested in finding magnetic field due to a solenoid. देखो कैसा रहेगा. ठीक है? So let's now make current flow through it. अब current कैसे देंगे? यहाँ से देंगे. Okay, let's give the direction of the current flow. अभी ना मजा आएगा. चलो आ जाओ. Very important. Okay, now stand here and observe from this side, because now you see the loop like this. Have you walked behind N tower and all? So on the boundary wall, do you see barbed wires like this? So you stand on the boundary wall and the barbed wire should go like this in front of you. You're like that. They're just standing in front of. चूड़ा देखा है ना? नई नई शादी. तो चूड़ा को सामने लेके खड़ा हो जाओ. ठीक है? क्योंकि लूप आपको इस साइड से देखना है. अब करंट कैसे जा रहा है? Let's just see the first loop. Okay? Just see the first loop. The current is entering in this direction, coming out in this direction, again going up. So how do I see the current going? आप लोग सब ऐसे सोचो तो कैसे दिख रहा है आपको? It's all moving from, I find the current is going in clockwise direction. Circular solenoid. I've kept the solenoid like this, and I find that when the current is entering, it's something like this. No, it's like this. So the current has entered, and the current is this is just reverse. Okay, this is a reverse solenoid. So the current is entering in this direction. So if I'm standing and I watch that the current is going clockwise, then don't I think that this pole should be the south pole? Yes. And stand on this side on the same solenoid. Now I see the current as anti-clockwise. So that should be the north pole. ठीक है? That should be my north pole. ये अगर समझ में आ गया, बहुत कुछ समझ में आ गया आपको. That should be my north pole. Understood? I take this diagram and I bring it little bit here now, like this. ठीक है? और ये जो हमारा आदमी है, इसको गायब कर देते हैं, इसकी और जरूरत नहीं है. Right? Now, if you take a magnetic compass and you start plotting the magnetic field lines, then you get very interesting magnetic field lines. North pole, south pole. So you will find magnetic field lines originating from the north pole and ending at the south pole. From the north pole, ending at the south pole. From the north pole, ending at the south pole. And inside कैसा होगा? So these will all go like this, like this, like this, like this, like this, like this. Yo, that's the thing. You have actually made a bar magnet. This is same. Now just see, can I not say that this item of mine is behaving like a bar magnet? समझ में आया?
Each loop में each section has its own.
सब जॉइन हो गया ना, ऐसा लंबा है वायर. बड़ी अच्छी सवाल है. पहला सर्कल में इस साइड से देखे तो साउथ पोल, फिर नॉर्थ पोल, फिर इस साइड साउथ पोल, नॉर्थ पोल. सो टेक मेनी ऑफ दीज स्मॉल मैग्नेट्स, फ्रिज मैग्नेट, एक के पीछे एक के पीछे एक के पीछे एक के पीछे लगा देंगे. बाय द वे, वेदर यू नो और नॉट, in batteries, if we connect them in series, the voltage increases. 2 batteries will give you more glow. Magnets also behave in the same manner. Suppose you need strong magnetization, 2 fridge magnet एक के पीछे एक लगा दो, वो ज्यादा stronger magnet. ये तो बहुत सारे हैं. N number of turns. So you are having N loops. Loop 1, loop 2, loop 3, loop 4, loop 5, loop 6, loop 7. N loops connected back to back in series. So very strong magnet has formed. Yes, now we have to come to. So do we understand how to find the magnetic field? Stand in front of the solenoid axis. Either way, you have the freedom to stand this side, or you have the freedom to stand this side. All you need to know is that you are standing on the end tower boundary wall, and the barbed wires are in front of you. And then see which direction the current is going. The mantra remains the same, CWS. But for you, sir, it is becoming CCW. CCW है तो N. ठीक है? So यहाँ हम क्या बोलेंगे? So we will say that the magnetic field, okay, the magnetic field is directly proportional to 1, the intensity of the current, I. Stronger a current that is flowing through the solenoid, stronger will be my magnet. Got it? Number 2, number of turns, directly proportional. N जितना ज्यादा होगा उतना ही बड़ा मैग्नेट होगा. Number 3, inversely proportional to the radius. Okay, inversely proportional to the radius. Now we will introduce one more thing out here in this. So far, how is my solenoid looking, बच्चा? My solenoid is looking like this. ऐसा, like a चूड़ा, न्यूली वेड गर्ल का चूड़ा जैसा है. ठीक है? अब आप सोचो, if I ask you to yell to your friend and you have very good yelling capacity, still how will you yell to somebody far away? हाथ ऐसे कर लेते हो. ऐसे क्यों करते हो हाथों को? रिफ्लेक्ट होके एक डायरेक्शन में जाए. सो हमारा जो ये मैग्नेटिक फील्ड लाइंस है ना, we have to make them, we have to make this magnet stronger. So we need a better amount of concentration. So what we will do, whenever we have our solenoid, so let's make one more solenoid. Okay, let's make one more solenoid. So this is the center line, and this is my solenoid. ठीक है, इस solenoid के अंदर हम क्या करेंगे? We are going to introduce something which is known as core material. What are we going to introduce? Core material. So the core material, it is like a rod which will be put inside it. This enhances the magnetization. Now a rod. This rod is made up of what? This is known as the core material. And the usual choice for it is soft iron and not steel. The reason is, what is your end intention? Your end intention is to design a magnet, slave magnet. It will magnetize to my wish, demagnetize to my wish. Have you gone inside ATM doors? When you press the switch, the door opens. Otherwise, the door just locks on the top panel. Have you seen those doors, glass doors? That means it gets magnetized, demagnetized. So the security will tell you, "Sab switch daba ke kholiye." So when you press the switch, it demagnetizes. I want my magnet to develop strength according to my choice. Can I do it? Yes. Control the radius and control the current. I want my magnet to change polarity the time I want. Change the polarity of the current. And I want my magnet to be strong. And also, when I switch it off, it should lose all magnetization. That is done by soft iron. So what is the beauty of soft iron? Soft iron magnetizes and completely demagnetizes. Completely demagnetizes when current is turned off. Turned off. If you would have used steel, steel will retain some amount of magnetization. That's the reason. If you keep a compass attached to a magnet, your compass is made up of mild steel. If you attach your compass to a magnet for say 48, 72 hours, and then take your magnet and put it on small pins, it will attract pins because it has retained some magnetism. But we don't want that. हम switch दबाएंगे, डिमैग्नेटाइज हो जाना चाहिए. अगर ये मैग्नेटाइजेशन को रिटेन करता है तो ये हमारा गुलाम नहीं हुआ. It has to be my proper slave. So I introduce a fourth item which is known as the core material. Do you understand? Then a fifth factor will also come in the next category. So magnetization depends upon the intensity of current, right? The number of turns on a solenoid, the radius. Smaller the radius, better the. So you won't find this, that you cannot forget. You won't find this big solenoids in your cellular phones. Your cellular phones have to have solenoids, and they will be very small. ऐसे बोलोगे एक spring गिर गया खोलते ही. That was a solenoid. You can in fact go to Google and type solenoid coils in a cell phone. It will show you small. And the core material. Sometimes we use core, sometimes, but if you want to have a good magnet. So this is solenoid, and this arrangement means when this is connected to a power source, the difference is I would call this as a solenoid. इसको क्या बोलेंगे? Electromagnet. यही है हमारा electromagnet. Got it? You can make it at home. Take one iron or a screwdriver's shaft. No need of insulated copper wire. Just use normal copper wire. Ensure that they don't touch. Connect it to a battery. गर्म होगा और कोई भी चीज को टचक ऐसे उठा सकते. ये सब मैं खुराफाती करते रहता था. तो ये उठते रहेगा ऐसे करके. हो गया मैग्नेट. आराम से. This is known as an electromagnet. A lot of things you have studied. First was Oster's experiment. Then magnetic field due to a current carrying straight wire, right hand thumb rule or the corkscrew rule. After that you understood magnetic field due to a circular loop, CWS. CWS from the direction that you see, remember always. CWS we apply to solenoid. What is solenoid? A solenoid is a closely wound large number of loops of insulated copper wire where the length of the solenoid is quite high as compared to the radius. When you pass current through a solenoid behaves as a bar magnet. And to enhance the magnetization, you introduce something called a core material, which is soft iron. Why did you prefer soft iron over steel? We prefer soft iron over steel because steel does not lose its magnetization completely when the circuit has been switch turned off, when the current flow has been turned off. Whereas if you have soft iron, it magnetizes 100% and demagnetizes to 0% when the current is. So it makes a perfect choice for electromagnet. And this now brings us to the scenario where we actually have a grade 8 topic, and that grade 8 topic will be, अगर ये क्वेश्चन आ गया हाँ तो आपके लिए बहुत ही अच्छा है, distinguish between an electromagnet and permanent magnet. So let us see what are the distinguishing feature. Number one, electromagnets can polarity can be reversed. Can you reverse polarity out here? No. Number two, strength can be varied. Can you do it out here? No. Number three, you can make strong magnets out here. In fact, do you know that your mixer grinder also behaves like a magnet? It magnetizes once you turn the mixie on. ऐसे जाके मिक्सी में screwdriver लगाइए, it will not attract. It has to become a magnet. Fan, any rotating device has to get magnetized. However, if you see the child cars, बच्चों की जो गाड़ियां होती है ना जो हम चलाते हैं उसमें मोटर रहता है, छोटे छोटे मोटर. Those motors will have permanent magnet. A motor has to have a magnet. A motor has to have a magnet, and those motors have permanent magnet because it has to move a toy car. But imagine if you have a mixie where the mixer grinder has to turn. There we don't have permanent magnets. There we have electromagnets. So you can actually design strong magnets in this case. Strong magnets, okay, which you cannot do in this case. And the fourth one, it can be magnetization can be introduced, okay, magnetization can be introduced and withdrawn. You cannot do this out here. So isn't this a lovely choice? So if I would have fitted a permanent magnet inside my mixer grinder, as day goes on, the permanent magnet will lose its magnetization one day. Have you seen your fridge doors? They have got permanent magnet. The fridge door has got a magnetic strip on it. As the fridge becomes older and older, the door closing does not become that strong, that intact. How to test whether your fridge is good or not? Take a 10 rupees note, put it between the door and close the door. If you can pull out your 10 rupees note, then your fridge is time to be, that bushing is supposed to be replaced. Otherwise, your fridge is leaking heat inside. So if I have a mixer grinder where I need strong magnetization and the magnetization to stay intact, better to choose to a magnet like this. So if you open a mixer grinder and you open the armature or something, you'll always see electromagnets made there. And those electromagnets will be actually working in this favor. Now, some of the type of magnet shapes that we have, you all already know what is a bar magnet, right? This is a bar magnet. Then we have another magnet which is known as the horseshoe magnet. Now let us see how a horseshoe electromagnet is made. This will actually bring a fourth parameter also. This is horseshoe electromagnet. So see how a horseshoe electromagnet is made. Just dekho, wait. So we will have our wire. My wire will go inside. These are the two terminals. And what is this? This is my soft iron core. You know a horseshoe magnet? Horseshoe magnet, permanent magnet you have seen. This is horseshoe electromagnet. Okay? So what did we write? The current that the intensity of magnetization depends upon what? Number one, the intensity of current. Number two, the number of turns, inversely proportional to the radius, the type of the soft iron core, and the fifth is also interesting, which is called the length of the air gap between the two terminals. The length of the air gap. More is the air gap, weaker will be the magnet. That's why horseshoe magnet एकदम ऐसा बनाता है, देखो. They don't make a horseshoe magnet which has got two legs on this side. No, horseshoe magnet is छोटा छोटा. the length of the air gap ये और छोटा रहेगा. This air gap should be less. So write that point also. Magnetization also depends upon the length of the air gap between the two poles. So in this magnet कैसा रहेगा जरा देखो तो. If we see, children see this side. If you see, how will you see now? You have to see it in this manner. Lie down and see from this side. If you see circular from this side, then this will become a south pole and this will become north pole. The distance between the poles should be less. Air gap. ठीक है?
What will happen if it's like more?
कमजोर होगा. आपको strong magnet चाहिए. See, when you design something, you will have many limitations. कैसा limitation होगा? Space का limitation होगा. This will be some part in your whole product. You will have space problem. You will have cost issue. कितना कॉपर दोगे? पब्लिक दाम नहीं देगा उसका. तो इसका एक एग्जांपल देख के आज छोड़ देते हैं. So let's see one of the nice examples. If you want, you can actually buy one and see, but I will suggest please don't handle electricity without knowledge. So one of the easiest example to understand is the calling bell that we have, the ding dong calling bell जो हम बजाते हैं ना, ting tong. It is just that ting tong bell कैसे बजता है देखो. Ting tong bell is actually the cheapest electrical appliance. Should not cost you more than 40 rupees. Nowadays by price inflation should be some 60-70 rupees. उससे ज़्यादा नहीं, 100 rupees. If somebody is selling this at 500 rupees to you, is making you an idiot. But not those bells, huh? जो बजाते ओम जय जगदीश, वो वाला नहीं है. This is a simple ting tong bell. ठीक है? अब ting tong bell कैसे बजता है देखो. Have you seen in ting tong bell? You have to understand when you press the bell, ting happens. When you release it, a tong happens. तो ये ting और tong दोनों देखते हैं कैसे होता है. ठीक है? इसके लिए क्या रहेगा? दोनों साइड में sonorous metal plates रहता है. I wish to make this as our project. तुम लोग खोल के नहीं देखते हो ना कोई चीज, इसलिए मजा नहीं आता है. Now, then we will have one electromagnet. अब अपना electromagnet कैसा रहेगा? Electromagnet अपना ऐसा रहेगा. This is like an electromagnet, but we will make it in style. इधर देखो, इधर देखो. We'll make it in style. ऐसे नहीं बनाएंगे. ऐसे बनाने से अपना काम नहीं होगा. Have you seen what do you call roller pulleys जैसे होते हैं ना? These threads. Many threads you see, right? जैसे jeans के thread होते हैं ना? They are all on roller pulleys. Once your thread is over, what you get is a black pulley, right? So we will have a black pulley. The black pulley is something like this. And on this black pulley, the electromagnet को ऐसे wound up किया रहेगा. समझ में आया? Now this item is then introduced out here. ये यहाँ पे introduced रहेगा. ठीक है? Okay, very good. So इसके आगे क्या करेंगे? This one will go to our mains board and there will be a call bell switch and this one is connecting out here. So as soon as I press it, this should get magnetized, right? अब इसके अंदर हम क्या करेंगे? We will have one hammer. We'll have a hammer inside. Right? We'll have a hammer. Now, this one of the plate will be a plate which will be magnetic material. And this side will be non-magnetic. इसको non-magnetic रख लो, but it is sonorous. This is also sonorous. This will be magnetic. ठीक है? जैसे ही आप इसको switch on कर देते हो, you turn it on, then this becomes a magnet and the hammer is free to move. So this fellow attracts the hammer and this will have a hammer head on it. ये जगह टंग करके मारेगा. It will go and hit there. But there the engineering is not complete. After that you will turn it off, it should get demagnetized. नहीं, tong क्यों करेगा? This is not magnetic. Why will it do tong? ये तो tong नहीं, not inertia. Why inertia? This is a free magnet. It just goes and hits tong करके hit कर दिया. Now you have made the current off in the circuit. I have demagnetized. I should remain here only ना. मैं उधर क्यों जाऊँगा? दिमाग लगाओ. अरे यही तो इंजीनियरिंग है. इसको हम कैसे रखेंगे? We will not allow it to go freely. Here they will introduce one spring, potential energy. So if you want to go there, compress the spring and go. So once the magnetization is lost, ये बोलता मैं क्यों आया था यहाँ, चल पीछे, स्प्रिंग उसको बुला के लाता, टंग करके दूसरा मारता है. And if you have some grudge on your neighbor and you want their bell to get bad, just keep it switched on for more than 6 seconds, immediately फट जाएगा. That is the first problem. Immediate. Any calling bell which has got ting tong, this one, mine, this is 80 rupees calling bell. मेरे साथ मत करना. अगर आप इसको ऑन करके रख दोगे ना, what will happen? This coil will heat up. As soon as the coil heats up, ये फट जाएगा. सस्ता है ना. And the ones which you have jingle bells, om bhu bhuva, उसमें circuits रहता है अंदर में. That's a preloaded song which is gets on played on what you call shuffle mode. So this is very easy. Have you understood how it happens? So this part of the plate will be magnetic and this part will be non-magnetic, though becoming sonorous. The hammer always remains on this side because the spring in its natural form will remain in unconstrained manner. And when the spring is unconstrained, the hammer remains this side. As soon as somebody presses it, ये magnetize हो जाता है, तो ये fixed रहेगा. These are fixed. These are fixed. So this one can't move. So what it will do? It will pull the magnet. ये टंग करके मारेगा उसको. तब तक आप इसको छोड़ देते हो. छोड़ते क्या होता है? Spring energized हो जाता है because you compress the, when you go to hit it, you're compressing the spring and going. Any device, if you have your tongs, if you have your pliers, you will always see no pliers, cutters. They'll always have a spring here. दबाने से तो मैं दबा दिया, छोड़ना भी तो चाहिए. गाड़ी का ब्रेक दबाया तो ब्रेक लगा ही रहेगा. ब्रेक शुड कम बैक ऑल्सो ना. सो दीज आर कॉल्ड सेल्फ एनर्जाइजिंग डिवाइस. अगर मैकेनिकल इंजीनियरिंग पढ़ोगे तो इसमें आप सीखोगे कितना एनर्जाइजेशन. अब ऐसा स्प्रिंग मत डिजाइन करो कि मैग्नेट हो गया मैं जा ही नहीं पा रहा हूं. स्प्रिंग कांस्टेंट हम पढ़ते थे. स्प्रिंग यू हैव डिजाइन सो स्टिफ कि बार स्प्रिंग को हिट करके जा ही नहीं पा रहा है. पेन का रिफिल, उससे हम रॉकेट बनाते थे क्लास में, ऐसे करके टक छोड़ते थे, दिस गोस लाइक अ रॉकेट. स्प्रिंग कैन बी यूज्ड टू, स्प्रिंग इतना बड़ा स्टेन गन चलता है स्प्रिंग के ऊपर. दैट्स व्हाई आफ्टर हेवी फायरिंग sometimes always they'll say that spring lock ho gaya. So the first thing in machine gun they'll do is uncork the gun, immediately open, take out the gun, again put machine gun. There are movie stories where they'll show that their co-sniper has hit, he's dead. उसको हटा के उसका गन खोल के उसका स्प्रिंग निकाल के फिर स्प्रिंग में बहुत कुछ कर सकते हैं आप. A spring can work wonders. If you have seen Bomkesh Bakshi type of episodes, then there is one episode where cycle के belt से लोगों का murder भी करता है. Pin. They load the pin and the police is unable to catch who is the murderer. People walk on the street. Every time people walk on the street and a murder happens, a cycle crosses them. And the cycle, ting tong bell बजाता है. Bell में क्या किया? ऐसा pin ले लेता है. And the pin goes and hits right at the chest. Death. ठीक है? So next class, we will go ahead from here. So please study up till permanent magnets and temporary magnets. विवाह नहीं आया मतलब डायबिटीज आप खा